All right, in this example, we're actually going to calculate a binomial distribution, okay? So it's a distribution that's associated with a binomial experiment, all right? Um, so in this experiment, we have a fair die that's rolled 5 times. And if a 1 or a 6 lands uppermost in the trial, then the throw is considered a success. Otherwise, it's a failure. And we want to find the probability of obtaining exactly um, 0, 1, 2, 3, 4, or 5 successes out of 5 rolls, right? So so we're so we're so we have five trials, right? So n is equal to 5, right? We're rolling this die 5 times. What's the probability of success? In this case, we're interested in either a 1 or a 6 landing uppermost. So the probability of success is going to be 2 out of 6, which is just 1/3. What's the probability of failure? It's just going to be 1 minus 1/3. So the probability of failure is going to be 2/3. All right, and then we're going to compute a binomial distribution. So essentially, we want all of the probabilities for all the possible outcomes. Okay, so this takes a little bit of work. We want to calculate the probability that x is equal to 0, which would be you don't get any 1s or 6s. We want to look at what's the probability of 1 success, what's the probability of 2 successes. We want to calculate the probability of 3 successes and 4 successes and so on, right? Equals 4. Probability of x equal 5. Okay, we only have to go up to 5 because we're only going to roll the die 5 times. So that's the maximum number of successes we can get. And then we're just going to use our formula, right? We're going to take the combination of we have n things, or taken 0 at a time, n and x. We're just going to feed in the values n and x. X is 0 in this first case. Probability of success is 1/3. We want that to the 0 power because we don't want any successes here. And then 2/3 to the n minus x, which is going to be to the 5th power. And that's going to give us the probability of having no successes. All right, now if I put that in my calculator, then I get 0.1317. Okay, so it's just a matter of repeating that again and again. So the next one's going to be a combination of 5 things taken 1 at a time, right? And then 1/3 to the x power, which is 1, and 2/3 to the n minus x, so that's supposed to be 3, to the 4th power. I put that in my calculator. I got 0.3292. Okay, and I'm just going to keep doing that all the way down. All right, so I've taken all of my, I've put the numbers in the formula for all these values of x and calculated the associated probabilities. And those are the numbers that we're going to put in our tabular probability distribution. Okay, so I'm just going to take these numbers and put them in my table down here. All right, so there we go. My possible outcomes are 0 successes, 1, 2, 3, 4, and 5 successes out of 5 rolls of the die, and I've just written down all of the possible or all of the probabilities for all of these possible outcomes that I just calculated in part A. And that would be my tabular probability distribution. But I can also show it as a histogram. So all I need to do now is just transfer all that information over to the histogram. All right, so one thing you just have to watch is that, well, so the horizontal axis is just going to be the number of successes, right? And we're going to have the 6 different outcomes, 0, 1, 2, 3, 4, and 5. Vertically, we're going to have the probabilities. And so sometimes you just have to worry about the scale. You have to think about what your scale is. And in order to figure out the scale, is just look at the range, right? It's anywhere from 0. This value down here is very close to 0. The maximum is about 3.3. So that's why I just made each grid line 0.1 in probability. So 0.1, 0.2, and 0.3. So I'm just incrementing by 0.1. And then I could just transfer those values over, right? So for 0, I'm at, my probability is 0.13. So that's about 30% of the way between 0.1 and 0.2. So I just tried to estimate essentially where it is. 0.33 is about 30% of the way from 0.3 to 0.4. So just estimating, where those probabilities lie. And that's pretty much it for that example, and I will meet you in the next video.